Hello and welcome back, everybody. Today in geometry, we're going to be looking at the slope of a line and also what does it mean for two lines to be parallel and also perpendicular when it comes to coordinate geometry. So the first thing we're going to do is define one of the terms that you hear about in algebra quite often, which is going to be slope then. So in our definition, we're going to say the following. We're going to look at 2 points, P1, which has a coordinate of x sub 1, y sub 1, that's how you pronounce it, and also P2, which has a coordinate of x of 2, y sub 2. Then the slope between the 2 points, that is going to be the slope of the line, is going to be y2 minus y1 divided by x2 minus x1. Or you could do it the other way around, which is y1 minus y2 divided by x1 minus x2. Both of them are going to allow you to get the slope, which is the same numerical value. But more importantly, what you should recognize is that it's really just the change of the y value divided by the change of the x value for each one of these. So it doesn't matter which one you choose, just make sure you keep it consistent, then you should be fine. Now, more importantly also, you can also consider this as rise over run because the change in y is the change in the vertical value, whereas the change in x is the horizontal value in change. So right here, you can see that that is going to be the change in y. Whereas this part right here, that's going to be my change in x then. So going to, a few of these examples right here, we can go ahead and find the following then. So let's say now for this one, we're given 3 points right here. We're given A, which is going to be -1, -3, B, which is going to be 5, 7, and C, which is going to be 11, 3. What I would like to do is I want to find the slope of the line for each one of these, AB, and then the second one, which is BC, and then the last one, which is going to be AC. So we can go ahead and use the slope formula for each one to solve for each one then. Now, AB over here, you can see that it's going to be this part right here. So I want to find the slope of this line. So the slope of AB, according to what we just said, is going to be the change in the y value divided by the change in the x value. So we'll go ahead and do B first if we want to. So we'll go ahead and say 7 minus, be careful now, -3 divided by 5 minus -1. So make sure you actually add those numbers because you're subtracting negative numbers. So as a result, you are going to get 10 on the top, and then on the bottom looks like it's going to be 6. So we can say that the slope, the change in the rise over the run is going to be 5 over 3 then. So that's going to be my quote-unquote ratio then, or the slope. Now, the slope in this case, because it's a positive number, then that tells you that it is an increasing function. So you can see right here, you can see how the line is going upward as you go from left to right. Now, let's go ahead and do the same thing for BC then. So this time, I'm going to go ahead and find the slope of BC, the line. And if you look at the picture, you'll notice if I draw from B to C, looking at it from left to right, your slope or your line is actually going to be decreasing. So what I'm expecting is that the slope is going to be a negative number. So let's go ahead and verify just to make sure. So from C to B, we're going to go ahead and say -3 minus 7, all divided by 11 minus 5. So that right there is going to give us a slope, which looks like it's going to be -10 divided by 6 over here. So that's going to be equal to -5 over 3. Now, if you want, we can go ahead and use the other coordinate around just to verify that it's still going to give you the same answer. So we can say 7 minus -3 divided by 5 minus 11. So that's going to give us 10 on the top and the bottom, which is -6, which also gives us -5 over 3. So it looks like that those two lines right there, they're going to have negative slopes of each other, which if you can kind of visualize it, then that means that those two are not perpendicular, but in a way, they are going to be congruent triangles if you were to kind of draw this right here in between them, because the slopes are going to be the same thing. In one case, you can see that the slope right here is going to be going up by 5 and across by 3, whereas the other one is going to go down by 5 and across by 3. Okay. Now, for the last part over here, which we're trying to find out what is the slope of the last one, which is AC. So the slope of AC over here is, once again, the change in y over the change in x. So -3 minus -3 divided by 11 minus -1. So the top part comes out to be 0 because it's -3 plus 3. And then the bottom is going to be equal to 12, which tells me the slope is equal to 0 because 0 divided by any non-zero number is always equal to 0. And when your slope is equal to 0, then that's also another way of saying that that line AC is horizontal. Okay, so the slope of a line, if it's equal to 0, then it's going to be horizontal. And if you're wondering, if you have a slope of a line for a vertical line, that one is going to be undefined then. So the slope of a vertical line is undefined. And when you get undefined, that means you get something like, say, a over 0, where a is going to be a real number that is not equal to 0 then. Okay, so maybe, for example, if you get like, say, 5 over 0, then you know that it's going to be some sort of vertical line. Or if you get -7 over 0, then that's going to be some sort of vertical line then. Numerically, a vertical line doesn't have a finite number of slopes. So that's something that you can also consider too. Okay, now let's look at this next one here, which is a theorem. Here in this theorem, we are saying that if you have a non-vertical line, and then all segments are going to have the same slope. So let's say that here, what we're trying to do is we're trying to find the slope of this line right here. And it says, this theorem basically tells you that no matter what 2 points you pick to find out what the slope is, it's always going to come out to be the same thing. So that is to say that as a restate, if A, B, C, and D are collinear, right, that's the most important part, and non-vertical because of the prompt that we're given, then the slope of AB would then be equal to the slope of CD. Okay, so this one we can probably do like as a proof, as a verification using geometry. So look at the two triangles that I've created over here, APB and then CDQ. I'm basically introducing point P over here and point Q over there such that you can see the horizontal increment and also the vertical increment. Now, this way we can see basically what is the change of x and over what is the change of y. But more importantly, you'll notice that the two triangles that I have right there, they both have right angles. So that tells me then that is something that we might want to consider. Now, the next thing is that these two lines right here, notice that we draw two parallel lines right here. So if we were to extend CQ over here, right? And then if we were to extend AP over here, those two are going to be parallel lines because they're both horizontal line. And if you have two horizontal lines, then that means that AD is going to be a transversal, which we cut it. So what that means is this angle C over here would then be congruent to this angle A over here. So looking at the two triangles, we have two pairs of angles that are going to be congruent to each other. So we can say that by AA similarity, that triangle APB is going to be similar to triangle CQD. So now what that means is that we can set up some sort of proportionality. And the proportionality I'm going to set up is that it's AP divided by BP is going to be equal to CQ and then divided by DQ. And if you look at each one individually, that's going to be the change of x for this part, and this is going to be the change of y for the other part. This is going to be the change of x for this part, and that's going to be equal to the change of y for this part. So as a result, they're going to be the same slope then, because, well, the slope of each one you can see is the same thing. Now, you can use actual numbers if you want to, just to verify, and that would actually work out too. Maybe that's a little bit better to understand. Okay, next, Theorem 13.2. Now, two lines are parallel if and only if they actually have the same slope. So meaning that if you have two lines, right, we're saying that if they are parallel to each other, then their slopes are going to be the same. And also conversely, if two lines have the same slope, then they are parallel. So this is kind of like a 2-for-1 offer in this case, because the theorem takes care of both the original and also the converse. So here on the right-hand side, you can see how that actually is going to happen up. But I think for something like this right here, it's probably best if I show it numerically instead of having to do the proof for this, because it seems very trivial for the most part. So it's probably better just to see it with actual numbers then. Okay. So let's say that you have a point over here. Let's see. How can I kind of draw this out? Okay. Actually, oh, I see what's happening. Let's go ahead and show it in the next example. That's what I want to do. That's the reason why I wrote this out. Okay, here it is. The example, I want to show that if I have these 4 points right here, these 4 points would then form a parallelogram. Okay, I want to show that if I have these 4 points right here, then that is going to be a parallelogram. Now, one thing we can do is we can go ahead and draw out like a generic picture just to see exactly what's happening. Okay, but we're going to go ahead and do a proof of this using what we're dealing with in terms of slopes. So A, which is going to be over here, is going to have a coordinate of 1, comma 2. So that's A. B has a coordinate of 4, comma 5. So that's maybe somewhere over here. So B is going to be 4, comma 5. Then we have C, which is going to be 3, comma 1. So that is going to be somewhere over here. So C is going to be 3, comma 1. Okay. And then finally D, which is going to be 0, comma negative 2. So that is going to be down here somewhere. So D is equal to 0, comma negative 2. So my picture, even though it doesn't look like it, oh, I know. I can draw B a little bit closer. Maybe that'll help out a little bit more. So let me go ahead and erase that top part over here. Okay, so there, here is A, B, C, D. And what I want to do is I want to prove that that is going to be a parallelogram. Well, let's think about what are some ways that we can show that you have a parallelogram then. Going back into the first semester, you need to show that something is a parallelogram. You have four different ways of doing it. By definition, the best way is to show that the opposite sides are going to be parallel to each other. Okay, show that the two pairs of opposite sides are parallel to each other. The other options is to show that the distance or the segments are going to be congruent to each other. Or you can show that the angles are going to be, the opposite angles are going to be congruent to each other. But unfortunately, since we're not dealing with angles when it comes to slope, nor do we know how to find the the segment, the length of a segment, the only thing that we can work off of is to show that some things are parallel to each other. So in short, let me go ahead and put on the side. I need to show, according to this picture, that AD is going to be parallel to CB. And in addition to that, I need to show that AB is going to be parallel to CD. So those are my two components that'll tell me that, hey, if those two sides are parallel, then therefore, if those two pairs of sides are parallel, then therefore we have a parallelogram by the definition. All right, so let's go ahead and do that then. Let's find the slope of AD then. So the slope of AD, we're focusing on this point and this point over here. So that is going to be, and let's go and flip it around. Let's do from A to D this time. So 2 minus negative 2 divided by 1 minus 0. So that means your slope in this case for AD is going to be equal to 4 divided by 1, which is equal to 4. So AD right here has a slope of 4, which is verified because you can see that it's positive and it's increasing. Now, what I'm going to do is I'm going to do the same thing for the opposite side. I want to find out what is the slope of BC over there. So the slope of BC, that's these two right here. So let's do it then. 5 minus 1 divided by 4 minus 3. So that's equal to 4 divided by 1, which is equal to 4. So that part checks out. Right there, we showed the first piece, which is to verify that one of the pairs of sides are going to be parallel. Now we just need to do the same thing for the other part. Need to show that the slope of this is equal to the slope of this. So let's go and finish it off. The slope of, what is it? AB in this case. So let's go ahead and use black in this one. So I want to find out what is the slope of AB. So that's this guy and this guy over here. So that's 5 minus 2 divided by 4 minus 1, which is equal to 3 divided by 3, which is equal to 1. Now find out what is the slope of the opposite side, which in this case is going to be the slope of CD. So that is going to be this piece over here divided by, setting up with this piece over here. So 5 minus 1 divided by 4 minus 3. So that's equal to 4 divided by, oops, sorry, I messed up. Not doing, I accidentally did DC in this case. I'm supposed to do A, B, and DC, not DCB. Sorry about that. So let me go ahead and change that. It's not supposed to be C and B. It's supposed to be C and D. My fault. So there we go. That's the one. Okay, so let's go ahead and solve for that one. Made a small little mistake, so hopefully you guys will forgive me for that one. 1 minus negative 2 divided by 3 minus 0. So that's going to be 3 divided by 3, which is equal to 1. So there you go. Now that we showed that both pairs of opposite sides are parallel because their slopes are the same, then therefore by definition of parallelogram, then you have a quadrilateral then. Okay. Sorry, the quadrilateral is a parallelogram then. Okay. All right, and this last part right here is something that is pretty essential, but I don't think they really ever proved it that much. They kind of cheated in terms of the proof because it was never really proven back in algebra class. What we have here are two lines. In this theorem, anyways, this theorem says that if you have two lines and they are perpendicular to each other, then that means that their slopes are going to be negative reciprocals of each other. And also vice versa because of the keywords if and only if. Remember, if and only if means that the statement is true and as well as the converse is true. So in this problem, what I'm trying to do is say that, hey, if the two lines are perpendicular, then their slopes should be the negative reciprocal. And at the same time, if their slopes are negative reciprocal, then that means that those are going to be perpendicular line. So here, just like with theorem 13.2, I think it might be, and also 13.1, I think it might be best if I actually show you numerically, so then that way you can come to draw this conclusion. So here we have 3 points. We have A, B, and C. B is basically going to be the intersection between the two lines right there. What I want to do is I want to look at the slope of each one and see how they're supposed to be negative reciprocal and also how they are supposed to be perpendicular to each other. So let's go ahead and set up some right triangle. I'm going to set up this right triangle over here. And then I'm also going to set up this right triangle that's over here, right? Because I want to look at the change in X and change in Y. Okay, so in the first triangle over here, the change in Y going from 7 to 2 right there, then that means that the change in Y is equal to negative 5. So meaning you have to go down by 5 in order to go from 7 to 2. Then the change in X, we're going from left to right. So that means we're going from 1 to 3. So that is going to be equal to 2 in this case. So if you wanted to, you can say that the slope of AB, the line, is going to be equal to negative 5 over 2 because that's your rise over run. Now, keep in mind that this is going to be a right angle because we're strictly looking at the horizontal versus the vertical. On the other triangle, we're going to do the same thing. We're going to go ahead and look at its rise over run. So for the rise, the delta y, that is going to be 4 in this case because you'll notice that B, going from left to right, you're going to go up by 4 in order to get to C. Whereas for the change in X in this case, from B to C, is going to be from 3 to 13. So that means that it's going to be 10 because 3 plus 10 is equal to 13. So now what I'm going to do is solve for the slope of that one. And the slope in this case for BC is going to be equal to 4 over 10, which is equal to 2 over 5. So you can see that their respective slopes right now are negative reciprocal. So now what I need to do is I need to prove that these two lines are going to be perpendicular to each other. Well, now let's go ahead and look at it a little bit more carefully. Note earlier we were saying that this part right here, that is going to be 4. Note this part over here, that's going to be 10. This part over here is 2. This part over here is going to be 5, or technically negative 5 because we're decreasing. But more importantly, if you take a look at what I kind of like highlighted from each triangle, that is a proportionality, right? Because look, the proportionality that I have right here is an SAS similarity. We have side, angle, side, and then we have side, angle, side. Because you can see earlier, as I said over here, 2 over 5 is equal to 4 over 10. Assuming that we don't care about assuming that we don't care about direction, then that means that when we look at just the length of the segments, then that's why it's going to be 5 rather than negative 5. But more importantly, as I said, hey, look, 2 over 5 is equal to 4 over 10. So that means that we have the side proportionality set up. The angle in between, as we said earlier, they are going to be right angles. So that means that, again, by SAS, these two triangles are going to be similar. So what that means is that by corresponding parts, I can now say the following. this angle right here, that is going to be the same as this angle right here. So here, let me just go ahead and make the mark. These two angles are going to be the same thing. And similarly, these two angles right here are also going to be the same thing right there, okay? And this is by, I guess, kind of like corresponding parts of similar triangles or proportional triangles are congruent to each other. So here is kind of be my last step. Let's go ahead and call this A. Let's go ahead and call this B. Let's go ahead and then call this A, and let's go ahead and call this angle B. Looking at my picture right there, we know that A plus B has to be equal to 90 degrees because we have two right triangles that we're working with. Now here's the final part. All the way down here, you have a big linear triplet, okay? And this part right here, we'll go ahead and call it question mark. So because of this linear triplet, then that means that A plus B plus the question mark, the angle in between the two sides, would be equal to 180 degrees. So then that means that, let's see, we're going to go ahead and make a substitution since A plus B is equal to 90. So 90 plus question mark is equal to 180. So question mark, the angle in between the two sides, is going to be equal to 90 degrees. So there you go. All right, so that is going to be your proof, quote unquote proof in this case. Now, can you actually use proof with variables? The answer is yes, but unfortunately, the proof is just very, very nasty in terms of like when you're using variables. So we're trying to use real numbers so you can have like a better grasp of it. But there you go. I should probably do it. And do I have any more? Oh, yes. Well, actually, I guess I don't have any more. We'll just go ahead and end it for right now. All right. Thank you so much for watching, and I will see you next time then. Have a good one. Goodbye.